look at the key term for this problem. We're going to approximate the change in surface area of the spherical hot balloon when the radius decreased from 4 to 3.9. Okay, we're going to approximate change in surface area. The notation for the area is A. Change, that's delta A of the spherical balloon. The shape is the sphere. Okay, that tells us they put things together as the delta A is approximately equal to the derivative or the change, what is it called? The derivative of the A because the function is A, right? Based on the notation that we use all the time as the delta Y equals the F prime at X times the delta X. This one means the Y equals F of X. So since A as a function of the radius, so in this case, A as a function of the radius. So the delta A approximately equal to the rate of change of the A or the A prime multiplied by the change of the independent variable, which is the R. Just imitate with the pattern that we know or from the skill problem as a general notation x and y. This time a as a function of the r. Or we can say that we're gonna find the change in radius. No, in area. Sorry, the change in surface area as a delta a, and approximated by the rate of change, which is the derivative of the a with respect to r when x starting at 4. So when r equals 4, and then multiply by the change in r. The next r, since it's decreased, so it decreased to 3.9 minus 4. That's gonna tell us about the negative side because it's negative, it's decreasing. Okay, so the delta A approximately equal to the rate of change of the A with respect to R multiplied by the change in R, which is negative 0.1. Okay, that's a setup. And put numbers together or look for the things that we can plug it in the equation. We already get the delta R. And for the A, the area of the sphere is 4 times pi times r squared. If you don't recall, you just look it up. That's fine. And if you need it for the exam, you can write it as one of the formulas on your note card. So A is 4 times pi r squared. So the derivative of the A with respect to r, or the A prime, is 8 pi times r. Okay? And we're going to evaluate when r equals 4 because we are looking at the point of reference or the point that r is 4 at the beginning of the change. Or we get 8 times pi times 4 or 32 pi. And then bring it into the main part of the problem. The change in the area is approximately equal to 32 pi multiplied by negative 0.1, or it's negative 3.2 pi. Okay, 3.2 pi. And the unit, since this is the change of the area is the two-dimensional quantity. This is the unit meter as a dimension. So the unit of the change of the area is meter squared. Okay, negative 3.2 pi is about, put in a calculator, is about negative 10.052 square meters. So this is the approximate change in surface area. Now we can check with the exact, okay, the exact change. Exact change, the delta A would be the A at the last point of the R, which is 3.9, minus the area at the reference point or at the point 4. So A at 3.9, which is 4 times pi times 3.9 squared minus 4 times pi times 4 square. And then you can do one more step as 4 pi as a common factor. Multiply by 3.9 squared minus 4 squared, which is 16. And the calculator should give you the negative number as negative 9.9274 and so forth. Unit is meter squared. And compare the numbers. The approximate is, oops, it didn't go. Approximate is, oops, approximate is negative 10.52, but the exact is negative 9.9. So they are close numbers. Approximate change in atmospheric pressure when the altitude increases positive because you see the z from 8 to 8.03. Using the formula, the pressure at z is 1,000 times e to the negative z over 10. The change in atmospheric pressure, the pressure with the notation P, so this is a delta P, approximate when that means when z equals 8 and changing from 8 to 8.03. So your goal is to find the delta P in the approximating form as a derivative of the P multiplied by the change of the Z, because the P as the function of Z at what? At Z equals 8. I should put the bar behind the prime here. At Z equals 8. Okay. So first we're gonna make a list on the right side here as since the P as a function of the Z equals 1,000 e to the negative Z over 10. The derivative or the d by dz of 1,000 e to the negative z over 10. Use the chain rule. E to the power is the same as e to the power, and then multiply by the derivative of the power, which is the derivative of the inner function, on negative 1 over 10. Simplify to be negative 100 e to the negative z over 10. This is on the side note that we're gonna get the thing prepared for the main part of the problem. You need p prime, you get p prime, but you're gonna compute at z equals 8, which is the point of interest with z equals 8. So negative 100 times e to the negative 8 over 10, which is negative 0.8. Be careful with the negative sign. So negative 100 times e to the negative 8 divided by 10, we get, uh, I got the number, negative 44.9328 and so forth. So put it in here as a change in pressure approximately equal to, just write the derivative first and then plug it in later. You can do that as well. So negative 8 over 10, this quantity, multiplied by the delta z, which is 8.03 minus 8, and the number, this number is about negative 44.9328 something more, and multiplied by 0.03. The change is positive because the key term increased and the last number is greater than the previous number. And next, multiply these two numbers, so we get the change in pressure about negative 1.34798 and so forth. So the problem might tell you to round to the 3 decimal places or 2 decimal places, so forth. So then, as you see, the change in pressure is negative. So that means for the position like in the higher, so the pressure is decreasing. Then you can check with the exact pressure as the P at 8.03 minus P at 8. Use the same function as 1,000 as a common factor. E to the negative 8.03 divided by 10 minus e to the negative 8 over 10. And the number should be close to what we got using the approximation form. Negative 804. Just 1 second. So minus I put the decimal place in the wrong one. Sorry about that. So 0.8. Just 1 second. So the number is very close as, oops, negative 1.3459. Close number. That's another way to verify.